Hello, sixth graders, and welcome to 6.2, where today we're going to be talking about comparing and ordering integers. For our learning target, we have I can use a number line to compare positive and negative integers. We're going to build a little bit from the last section where we learned that integers are the set of whole numbers, or sometimes we say counting numbers, and their opposites. And we're going to actually compare some now. So we're going to see which one is bigger and which one is smaller and so on and so forth. Okay. So for our first key idea, what we need to remember is that numbers to the left on a number line are always less than numbers to the right. That's always going to be the case. And numbers to the right are always greater than numbers to the left. Right? You'll see that here in just a second. And it's the same with vertical number line, but numbers below are less than numbers above. Kind of like a thermometer. If you're reading a thermometer, the higher up the thermometer goes, or the mercury inside the thermometer, the higher up that goes, the hotter it is, the bigger the number. Okay? And the same is true for the opposite. Numbers are greater, numbers above are greater than numbers below. Okay, so what does that look like on a number line here? Well, example 1 says compare 2 and negative 6. Well, the first step you would do would be to create a number line here, which they've already did for you, and then graph negative 6 and graph 2. And now think to yourself, which one is further to the left? Well, negative 6 is further to the left, so that's going to be less than. And 2 is further to the right, so that's going to be greater than. So if I were to compare 2 and negative 6, 2 is further to the right, so it's greater. So Pac-Man will eat the 2 then, or the alligator, or however you learned it. Okay, so really we're just looking for less than or greater than. And anytime you have a positive number and a negative number, it should be pretty clear because positive numbers are always going to be greater than negative numbers. Okay? What about if you had a situation that was on a vertical number line and it says compare negative 5 and negative 3? Okay, so compare negative 5 and negative 3. Now we have a situation where we have two negative numbers. Okay, well, just like before, except now this is a vertical number line. Numbers that are lower on your vertical number line are going to be smaller. All right, so in this case, negative 5 is underneath negative 3, so that is smaller. So negative 3 is actually greater than negative 5. Okay, Pac-Man will eat the negative 3 because negative 3 is greater than negative 5. Negative 5 is less than negative 3. It's below it on a number line. All right, go ahead and pause the video here for the first section of On Your Own Problems. Number 1, 0 is greater than negative 4. It's kind of weird that 0 can be bigger than something, but now when we introduce negatives, it kind of seems logical. Number 2, negative 5 is less than 5. Again, positive numbers are always greater than negative numbers. And in the last one, negative 8 and negative 7 is greater. If you put it on a number line of, let's say, a horizontal number line, negative 7 is further to the right. So numbers further to the right are greater than. All right, questions on those, let me know. Moving on to the next two examples, it'll ask us to order integers in example 3 and also graph them on a number line. So here, a number line isn't provided. You'll just have to sketch one and take a quick look at your numbers to see what you should go by and how big you need. All right, my biggest number is 3, so I'll just start with 4. 4, 3, 2, 1, 0. -1, -2, -3, -4, -5, and it looks like that'll be enough for me. I'll then go on to plotting my points. So I've got -4 right there. I've got 3, that's right there. Got 0, I've got -1, and I've got -2. Okay, now it wants me to order those from least to greatest. So now that it's on a number line, it's pretty nice to see. I'll just go from left to right because numbers furthest to the left will be the smallest. So it would be -4. Next up would be -2, then -1, then 0, and lastly 3. Numbered from least to greatest, and you can see my number line was pretty handy there because I could just visually now go left to right and have it ordered from least to greatest. Example 4 is a little bit of a reasoning problem. It says a number is greater than -8 and less than 0. What is the greatest possible integer value of this number? All right. Once again, I want to be able to see this a little bit better. So I'm going to make myself a number line. It can be really helpful. Greater than -8. So I know it has to be to the right of -8. -6, -5, -4, -3, -2, -1, and 0. And then we'd go 1, 2, so on and so forth. Okay, it's greater than -8. So here's -8. It has to be to the right of this because it's greater than -8, and it's less than 0. So here's 0. It has to be to the left of that. So it has to be somewhere in this range. It says, what is the greatest possible integer value? So the biggest number, or in other words, the number that's furthest to the right in this set of data. All right. Well, -10 for letter A is outside of this data. That wouldn't even be a possible answer. -7 would be here. -1 would be here. And 2 is also not even in this data. Doesn't meet the requirements of being from -8 to 0. So if I look at the two possibilities, -7 and -1, which one is the greatest? Well, remember, greater numbers are to the right. So the number furthest to the right is -1, which is letter C. All right, with the last example here, it says that the diagram shows the coldest recorded temperatures for several cities in Virginia. Which city has the coldest recorded temperature? And again, I think I said this before, but for us, this isn't that difficult to see because we're used to negative temperatures, and we understand that the more negative a number is, the colder it is. So we've got 0, got -3, -10, -11, and -12. Which city? That would be Richmond. If you were to graph this on a number line and say this was 0, and your negative temps are going like this, -1, -2, which one is furthest down? That would be Richmond, -12. Okay. Letter B says, has a negative Fahrenheit temperature ever been recorded on Wallops Island? And explain. Well, here's Wallops Island. It's sitting at, and I'm not sure if I'm saying that right. I'm sorry if anybody is from there and I'm pronouncing that or butchering that wrong, but it says that it's 0 degrees Fahrenheit is the data that I have. And remember, in the beginning, it says that it's the coldest recorded temperatures for that city. So the coldest it's ever been here is 0 degrees. So has a negative temperature ever been recorded? No, it hasn't. And why? Well, because the coldest temperature that's ever been recorded is 0, which is greater than every negative temperature. So again, there's never been a negative temperature recorded in that city. All right, to finish up today, please try 4, 5, and 6 with the on your own problems and come back in just a second to see if you got them correct. All right, for number 4, you should have came up with -3, -2, -1, 1, 3. Number 5 should be -8, -7, 1, 4, 6. For number 6, should come up with -7. And for number 7, should be the new record low. What integers can represent the new record low in Norfolk? That would be -9, -8, -7, -6, -5, and -4. All right, that will do it for section number 2. Please let me know if you have any further questions, and I'll do my very best to help. I will see you next time.